Section 6.6 is dealing with, notice the title, it says Special Quadrilaterals. So really, today we're not going to be talking about any new quadrilateral, okay? Last night was, last night was the last set of new quadrilaterals, okay? So this one is just tying it all together. I think this, to me, of all of these sections, this one is probably the one that is kind of more useful to kind of preparing for the test, because of the fact that it forces you to have to really know, okay, what is a parallelogram? What is a rhombus, rectangle?
Mm-hmm.
All the different
types.
Okay, so this is more just tying everything together. So no new concepts, it's just applying everything. Okay, so just kind of keep that in mind. Now, this first slide, notice it says we're doing a flow chart. Now, you've seen a flow chart in other classes. Sometimes you hear it as like a concept map, things like that. So basically, when a flow chart, you start with kind of the more broad concept, and the broad concept is quadrilaterals.
Yeah.
So now we're going to branch off of that, all the different specific quadrilaterals we've learned.
Okay. So like we've talked about parallelograms. So that would be a branch off of that because it's a type of a quadrilateral.
And I like that you start with parallelogram because it's not the most specific parallelogram out there. All right, or a specific, because there's more specific parallelograms. More like a square is pretty darn specific. So we want to start more broad, and kind of work our way, kind of branching it out. All right, so I'm going to branch off here and say, okay, we have a parallelogram.
Okay, we also talked about, we can go more in depth with that. I see where you're saying now, but let's go to the other types of quadrilaterals that we've looked at that are not parallelograms. Okay, so we've got parallelograms was one type, but then we had trapezoids, and those were not parallelograms. Those were a different type of quadrilateral.
And why aren't trapezoids considered a parallelogram?
Well, because they don't have two sets of opposite sides parallel. Just one set of opposite sides would be parallel.
And what do trapezoids and parallelograms have in common?
They're all quadrilaterals.
So that's why they branch off of that. But they don't. We're not putting trapezoid down here because doesn't have characteristics of a parallelogram.
Okay. And the other thing we talked about yesterday was a kite.
Yeah, so we can branch that off of a quadrilateral because a kite is not a parallelogram. It's not a trapezoid. So those are kind of the three most broad quadrilaterals out there.
Okay.
Okay, so let's go more specific. Maybe branch off of the parallelogram.
Sure. Okay. Like, so within parallelograms, we talked about we could have rhombuses.
Okay. What else?
Rectangles and squares.
Okay. So we want to start more broad.
Okay. Now I remember, a square was really both a rectangle and a rhombus. So let's go with rectangles and rhombuses as maybe branches off of parallelograms.
Now, why wouldn't I want to branch a rectangle off of a rhombus?
Well, because it does branch off of a rhombus, but it also would branch off of a rectangle too. Wait, did I say that right? Sorry, I'm thinking of square.
Why would I want to branch off the rectangle off of a rhombus?
Oh, the rectangle off of a rhombus, yeah. Well, because the rectangle and rhombus have different characteristics.
Yeah. They have, what do they have in common?
They're all parallelograms.
They're all parallelograms, but a rectangle doesn't have to be a rhombus. It doesn't have to have all congruent sides.
It only would be if it was a square.
So we're going to branch those off because they do have stuff in common. They're both parallelograms, but they don't necessarily, like, we don't have to have a rectangle that's a rhombus, right? So you said square, so square is branched off of what? Like a parallelogram, just put it off of the parallelogram?
No, it's really branched off of both rhombus and rectangle.
So to show that, let's just kind of show branches off of each of those.
Okay.
Because if you think about it, and the great thing about this flowchart, it kind of allows you to think, okay, well, a square has characteristics of a rhombus, as well as a parallelogram, as well as a quadrilateral. Square also has characteristics of a rectangle, kind of seeing that connection. Okay, so when we start kind of asking these questions coming up, if you need to go back to this flowchart to kind of see those connections, this would be a good idea.
Okay.
All right, let's move on. What about a trapezoid? Can we be more specific?
Well, we did talk about isosceles trapezoids a lot. So that would be a more specific type of trapezoid.
And I like that you said that because it is the more specific one. Now, are all trapezoids isosceles?
No, definitely not.
So we can break off of that.
Okay.
All right. And a kite?
We didn't look at anything more specific with a kite. It was just a kite was just a kite.
Exactly. So this, again, this might be something we might come back to if we need to. All right?
Okay. All right, this next slide. This is one of those things that I would say most of my students would say this was kind of helpful to really look at all the different properties of all these different types of quadrilaterals, these special quadrilaterals. You know, there's other quadrilaterals that aren't even in any of these criteria too, that just have 4 sides. These are the special quadrilaterals.
Well, and even the properties, those are not all the properties out there. We just listed a few out there just so we can start kind of thinking about it.
Yes.
Okay, so what are we needing to do here?
Okay, so I've got a property, a characteristic. It says both pairs of opposite sides were congruent. What figures had both pairs, and that's the key here, both pairs of opposite sides congruent?
Okay, so the first one says parallelogram, then a rectangle, rhombus, kite,
Square,
kite, and trapezoid. So I'm thinking the characteristic of both pairs of opposite sides congruent. I would say that's a characteristic of a parallelogram.
Right, it is. And that's one of the properties of parallelograms that we looked at.
There was a theorem that said if there's a parallelogram, both pairs of opposite sides are congruent. So that would be a parallelogram. But then I'm thinking, well, if I think back to that flow chart that I just did, anything underneath a parallelogram would have that same characteristic. So rhombus, rectangles, and squares would have that characteristic. So I can say rectangle has that property, rhombus, and square. Now, it says both pairs of opposite sides are congruent. In a square, all the sides are congruent, but if you think about it, the opposite sides are still congruent. Same with a rhombus. Now, kite, this wouldn't be a property of a kite because a kite, actually, the opposite sides can't be congruent.
It's the consecutive sides, right?
So no on that. And a trapezoid, you could have one pair be opposite being congruent. It could be like the 2 legs, but the other 2, the bases, can't be congruent ever.
Right.
So that would be a no on that.
And I love how you said that if something is a property of a parallelogram, it will be a property of all types of parallelograms. So if I put a check mark in this box, I know I need to check the rest of those boxes too because they're all parallelograms. So if it's a property of a parallelogram, it's a property of all parallelograms.
Exactly.
Okay, diagonals congruent.
And guys, and this is something we probably should have mentioned, this is a slide maybe you want to think about. We did the first one with you, but maybe from here, like you start checking in the spots and then like pause it and come back and see if you got the right thing.
Definitely.
Okay. All right. So diagonals are congruent. Okay. So I'm thinking, and if it helps to like draw a picture of some of these things to kind of see, it might help. Okay. So if I'm thinking of a parallelogram, you know, that's not a property of a parallelogram.
It's not a property
I know that the diagonals bisect each other in a parallelogram, but that doesn't mean that they're going to be congruent. So it's not a property of a parallelogram, which means it's not automatically a property of a rectangle, rhombus, and square, but it could be.
Right.
Okay, so I'm thinking in a rectangle it is.
In a rectangle it is, you're right. We know that those diagonals are congruent. And just as a reminder, what do we know about the diagonals of a parallelogram?
They bisect each other.
Right, because we do know something about them, and we'll get to that a little bit later. If you're just thinking, oh, I know something about diagonals, that doesn't mean that they're congruent. So really make sure you're thinking about what those properties actually tell us. Okay, so you're right. It is a property of rectangles, which now, thinking back to what we did on the last one, we said if something was a property of a parallelogram, it's a property of all parallelograms. So if something's the property of a rectangle, it should be a property of
a square.
Yeah, because it's also a type of a rectangle.
So we can go ahead and put in a box in that. And it's not a property of a rhombus. Kite, it's not a property of a kite.
Right.
Trapezoid, only if it's an isosceles trapezoid. So we probably wouldn't want to put a check in there.
I'm just going to make a little note.
Yeah. It's not works for all trapezoid. It only works for isosceles.
Yes. Okay. Now let's talk about the diagonals being perpendicular.
Okay. That's not a property of a parallelogram.
Correct.
It's not a property of a rectangle. It is a property of a rhombus, and that means then a square.
Right. If it falls in either a rectangle or a rhombus category, it definitely falls in the square category. Okay, what about a kite?
They were perpendicular in a kite.
They were.
That was kind of the unique one. And that was, again, remember that's the one, just when you watched the nice last night, just because the diagonals are perpendicular doesn't guarantee it's a kite or a square or a rhombus. You first have to know what kind of quadrilateral first.
Right.
It doesn't work for a trapezoid.
Okay. Now, diagonals bisect each other.
Well, that was one we already mentioned. That's a parallelogram, which means rectangle, rhombus, square. Now, in a kite, I know that one of the diagonals ended up being bisected, but it doesn't bisect each other.
Right.
Not both of them. So that doesn't work. And then a trapezoid also does not work.
Okay.
Consecutive angles are supplementary. That's a wrong, or not wrong, parallelogram first.
Yes, and if it's a parallelogram, it meets all parallelograms.
Okay.
Now, what about a kite?
No, because consecutive angles are supplementary. That means we're going to have some parallel. And
Right.
kites don't have parallel.
Exactly.
Now, trapezoid.
Trapezoid. Now, that's a trickier one.
Okay, in a trapezoid, maybe draw a picture to kind of get a
Okay.
visual of this. In a trapezoid, we know we have one pair of parallel sides, only one. So we do have some of them that are supplementary, the ones that are like not base angles together, like those
Right.
two and those two, but the base angles together are not going to be supplementary because otherwise it would be a parallelogram.
So it's not true that all consecutive angles are supplementary.
And so that's kind of a property specifically to parallelograms. Just like the diagonals bisect each other, just like the both pairs of opposite sides are congruent.
Right.
Okay.
Okay. Now, this last one, it said both pairs of opposite angles are congruent.
Well, that's just a property of a parallelogram, which means rectangle, rhombus, and square.
Yes. Are opposite angles congruent in a kite?
Only one pair, but not
One
both
pair,
pairs.
Yeah.
And then in trapezoid, that won't
I just
happen.
put that as just a reminder. Don't forget there is that one pair. But trapezoid, yeah, definitely not. What angles are congruent in a trapezoid?
The base angles.
The base angles. Sorry, guys, it's kind of skipping on me. Base angles. And I'm not checking these boxes. I just want you guys to remember some of those properties because there are some significant things about those figures, but it's not that property. The opposite angles are congruent.
Okay. So the rest of these examples are going to kind of, some of them are going to ask you to decide what kind of quadrilateral it's going to be based on some characteristics. So it's really applying, do you really know these properties? Not just the definition.
Yes, and that's what I was just going to say. I know a lot of students that just know the definition but don't know all the properties about these figures. This is a chapter you have to know the properties.
Okay, so here's the deal. It says ABCD, so obviously it's a quadrilateral, has at least two congruent consecutive sides. What quadrilaterals meet this condition? Okay, so if you need to go back to that slide, the flow proof, okay, or not flow proof, flow chart, these are all the different special types. Okay, so that's what we're kind of feeding off of. All right, so ABCD
I'm thinking
has at least two congruent consecutive sides.
Okay. So it's not going to be all parallelograms because those were opposite sides that were congruent.
Yeah, so a parallelogram, if you kind of get a visual, that means opposite sides are congruent. Do they have at least two congruent consecutive sides?
Not necessarily. Now, I can't think of a specific parallelogram that would work.
Okay, what one?
I'm thinking if I have a rhombus.
Okay, let me write that down. So rhombus, if I draw a picture of that, what do we know about rhombus and its sides?
All the sides are congruent.
So do they have at least two congruent consecutive sides?
Yeah, they're just all congruent.
Yeah,
but
at
yeah,
least
that
meaning
means
two or more.
that's the minimum. And so yeah, definitely.
Okay, so rhombus would work. Any others?
In a square.
Okay.
Because that's a type of a rhombus. So if a rhombus works, a square should work as well.
And if you need a visual of that, remember, think about all sides are congruent here.
Okay, and now I'm thinking consecutive sides being congruent. We talked about that with kites too.
Oh, so if I drew a kite, we know it has two pairs of consecutive congruent sides. Do they have at least two congruent consecutive sides?
Yeah, they do.
Yeah, so kite would work as well. Right, the only thing that you haven't mentioned was a rectangle and trapezoid. What do you think about those?
Well, a rectangle, no, because the two consecutive sides are not the same length.
Okay.
They have to be a square for them to be the same length. And a trapezoid could.
Yeah.
I mean, I could draw one that would.
So like these sides could be the same.
Yeah, but it's not a property of all trapezoids.
Yeah,
It doesn't work for all.
But it could work. The thing is, it says what quads could meet this or meet this condition. Technically, you could say trapezoid could work, all right? But it's not like you said, it's not a property of it.
Right.
We're looking more for the properties, which these are the three here.
So we would not want to put trapezoid here because that's really not all trapezoids
Exactly.
do.
It only works for special
But it
kinds.
only could for, okay.
Yep. Perfect.
All right. You guys love the coordinate plane so much that we decided to go ahead and come up with another one where you're deciding what kind of quadrilateral this will be. Now, I want you guys to just stop for a minute. We're not drawing this on a coordinate plane. I'm going to do a little sketch.
Okay.
All I know is that it is a quadrilateral because they call it ABCD. So I'm just going to draw four-sided figure ABCD. The only reason I'm doing a sketch is because when we start talking about either, we could talk about opposite sides, opposite angles, consecutive sides, and being parallel, congruent, diagonals, whatever things we want to talk about with these, it helps sometimes to be able to have that visual, to be able to know what pieces we're talking about.
And notice how she labeled it kind of in order. Don't do A, B, and then C, D, because that's not quadrilateral A, B, C, D.
Yeah,
okay?
Make sure it's whatever order you're going just around the figure. Okay. All right, now, Mrs. Palermo, we have learned so many things about these quadrilaterals. We don't know if this is a parallelogram, if it is and really kind of thinking about our broad spectrums first. We don't know if it's a parallelogram, we don't know if it's a trapezoid, we don't know if it's a kite. And then if it is a parallelogram, we have to get more specific if we can too.
So we kind of need to kind of maybe eliminate things to kind of narrow it down where we're even going.
Right.
Okay. So I like that you said that, because the ones that we've done so far with coordinate plane, they've been dealing with specifically parallelograms. So we've told you they're already a parallelogram.
Right.
Or yesterday, we just told you to just show that it's a trapezoid or show it's a kite. So there's things we already had to do. So the fact that they're just saying this is a quadrilateral, what kind is it? We need to kind of narrow it down. Okay. Right. So what I think I would like to do is first decide if it's even a parallelogram. Because if it's a parallelogram, we can go a little more specific. If it's not, then maybe we can determine if it's a trapezoid, because there's some characteristics. And then, of course, also a kite.
Right.
Okay. So I'm going to go with trying to decide if it's a parallelogram first by deciding if the opposite sides are parallel. Because if the opposite sides are parallel, then we can eliminate trapezoid and kite, right?
Yeah.
Okay.
So I'm just going to I'm going to write down what we said we're looking for. Okay. Sometimes it helps to know where you're going, and what you're trying to prove. So opposite sides parallel. That's our question. Are they? Okay, let's find out. So to determine if they're parallel, what are we going to be looking at?
We have to find the slopes.
Okay.
So let's do AB.
So the slope of AB, I'm going to take what?
Let's see, AB, 8 minus 5 over 1 plus 2. So that's 3 over 3, which is 1.
Okay, so slope of 1. Now, do you want to stick with the opposite sides, or do you want to go consecutive?
Yeah, I'll go to opposite. Let's just do that. Kind of skibby there. So DC now. And that is 2 minus 5 over 1 minus 4. So that's negative 3 over negative 3.
Which will end up giving us still a 1.
1. Okay, so far, let's go ahead and label in the picture.
Yeah, good idea.
So AB is parallel to DC. So, okay, so right away I know that it's a parallelogram, right?
Well, we know one set of opposite sides are... We could do one set of opposite sides parallel and congruent if you want to. Or I like since we already wrote down our goal right now is to see if all opposite sides are parallel, let's keep up with that approach.
Well, the only reason why I make that comment is because I remember in class recently I've had students that only did 2 slopes and said that's enough. We can't determine anything yet.
Because it could be a trapezoid.
It could. So all I need to do, now I need to go ahead and find the slopes of the remaining 2 sides. So let's do AD. So that would be 2 minus 5 over 1 plus 2. So it'd be negative 3 over 3, which is negative 1. And then BC, the slope of BC.
Yeah. Okay.
It'd be 5 minus 8 over 4 minus 1. So it'd be negative 3 over 3, which is also negative 1. So that says that those 2 sides are parallel as well.
Okay. So we know that this is for sure what?
A parallelogram. So maybe make a note of that off the side. We know it's a parallelogram. Okay. So now the question mark is it a specific type? Because it may not be. It may just be a parallelogram. Maybe it's a rectangle. Maybe it's a square. Maybe it's a rhombus. Now, One thing that I'm also noticing, and I don't know if anybody's thinking this, but finding the slopes of all the sides could also help eliminate between a rhombus and rectangle.
Yes.
Okay, and what's the difference between a rhombus and rectangle? Well, one of the big differences with slope, this is what I'm thinking about, is a rectangle has perpendicular or right angles in a sense.
Right angles.
Which involve perpendicular.
Right, so if we look at the slopes of these lines, if I look at two adjacent segments.
The consecutive or adjacent. So like AB, let's look at AB slope.
So AB we said was 1.
And then let's do AD slope.
Was -1. Now, to be perpendicular, their slopes would have to be opposite reciprocals.
Or the product be -1.
The product be -1. Well, it may be easier on this one to almost look at the product being -1, but they are also opposite reciprocals. If you look at a positive 1 over 1 or a -1 over 1, I could flip that and it's still going to be, and their product is -1 when we multiply. So you're noticing that these are. So we could say that they're all right angles.
And why are they going to all be right angles? Well, because if we already know this is parallelogram, right? We've already decided that. So that angle A, if you go to that picture, label that a right angle. Well, that means the opposite angles are congruent because it's parallelogram, and consecutive are supplementary. So that means all 4 of the angles are right angles. So that means we know for sure it's now a rectangle. Okay. So far, we haven't narrowed it all the way down. So we know it's a parallelogram and also a rectangle, but we're trying to be as specific as possible.
So the question is now,
is it a square? Now, before we move on, something I just was thinking while we were talking about these slopes with the opposite reciprocal, the only downfall to that is, what if you get a slope of 0?
Yes.
What would be the perpendicular slope to a slope of 0?
Well, that wasn't perfectly horizontal, but yeah, 0 slope is a horizontal line. Perpendicular to that would be a vertical line, which is an undefined slope.
So if you get a 0 slope and then an undefined slope, those would form a right angle as well.
Right.
Okay, so just remember that, because I think that's happened before, but I can't remember. But, it's good to know. Okay, so now we got to decide if it's a square. Now, I'm thinking of a variety of things you could do. All right, we already know opposite sides are congruent. We also know, because it's our parallelogram, we could also look at the diagonals too. Okay, I'm thinking
what was true of a rhombus but not a rectangle?
In a rectangle or a rhombus, the diagonals were perpendicular, and a rectangle, they were not necessarily. So if I could show the diagonals were perpendicular or not, then I could determine if it's a rectangle or a square.
So here's the thing. Yeah, we already know it's a rectangle. The question is it also a rhombus to where it's a square? We know it's not just a regular old rhombus because we have the perpendiculars, but it could be the square, which means that it would have the characteristics of a rhombus. Okay, so that's one approach we could do. Another thing we could do
is find the lengths of just 2 consecutive sides.
Yeah.
The one thing, the reason why I kind of pick out the diagonals is because notice I'm doing the slope formula 4 times so far, and I just need to do it 2 more times. So I'm not having to use any other formula.
I'm not even using distance formula at all.
Yeah, and I know some of you prefer maybe one formula to the other. So this gives you options. All right, so let's do the slope of AC, which is one diagonal. And that would be, looking at AC, that would be 5 minus 5 over 4 plus 2. So it'd be 0 over 6 is equal to 0. Oh, I didn't even know that this was going to happen, honestly. I was just thinking about it. Okay, so BD slope. Do 8 minus 2 over 1 minus 1, which is 6 over 0, which is actually undefined. So based on what we just talked about, what does that mean about those diagonals?
That means that the diagonals are perpendicular.
And so that narrows it down. Okay, we already know it's a parallelogram, and we know, based on what we've done, that it has characteristics of a rectangle, but we also know it has characteristics of a rhombus too, which means that together that makes up a square. So my answer is square. So a lot of work. Notice I had to do 6 different things, and that's pretty common.
Yeah, before we were only doing 4 because we were only working within the constraints of it was a parallelogram. When you're finding just what type of quadrilateral it is, at least 6.
Yeah. So now if it asks you to explain, that would, you would have to kind of talk about what you did. Okay, I found that the opposite sides had the same slope, so that means that they're parallel. All right. Then I found that the consecutive sides, or there were 4 right angles. Okay. I also found the diagonals were perpendicular. All these different things that happen. All right. Let's see if we can move
That
on.
would be a great test question.
Hint, hint. All right. Now, what about this one? It says, which 2 segments or angles must be congruent to enable you to prove ABCD is the given quadrilateral? Explain. Okay, now, one thing I want to stress is that it says which 2 segments or angles. So you're talking about 2 segments having to be congruent or 2 angles have to be congruent. Key here, congruent. So you're not saying, okay, well, this is a right angle or whatever, or these are supplementary. You're talking about
Congruent.
What do we need to enable that this would be that given quadrilateral? Okay, so, and then we're going to talk about the explanation. So if you wanted this to be a rhombus.
Okay, so I'm looking at the picture, and I can tell right now that it is a parallelogram.
And why do you know that?
Because opposite angles are congruent.
Now, these are congruent.
And the other one's not in there, but that would be a 65.
Yes.
Because if you do 360 minus the others, that would leave you with the 65.
So we already know it's a parallelogram. What does that mean?
That, well, a rhombus is just a type of a parallelogram. So I already know opposites.
Opposite sides are congruent, right?
I know opposite angles obviously are congruent. What we want to be able to prove to say that it's a rhombus is that really all the sides are congruent. Now, since I already know the opposite sides are congruent, I just need, and I only want 2 segments to be congruent.
So which 2 could be congruent?
So
would have
I want
to be congruent.
2 consecutive ones, or 2 adjacent sides.
Okay, so adjacent or consecutive.
Yeah. So I'm looking at maybe if I say segment AB.
Okay.
I would want to show that AB is congruent to either AD or I could have said BC.
You just need to give me 2.
Yeah,
right.
and
There's a lot of options here. Make that D look a little bit better. Now it says explain. So how would you explain that?
I would say that I know it's a parallelogram.
Okay.
So I wanted. So in order for it to be a rhombus, I know I needed to show 2 consecutive sides were congruent.
To enable that the fact that all of them will be congruent. Because if opposite sides are already congruent, well, if AB is congruent to AD, well, that means then AD is also congruent to BC, and that makes all of them congruent.
Right.
Okay, so just kind of thinking about that. Okay, what about the next one?
Okay.
We're trying to think about what would I need in order to prove that that was a rectangle. So think about what you already have.
Okay, so I'm looking at this, and I know that the diagonals are bisecting each other, which that is a property of all parallelograms. So I already know it's a parallelogram. I need to be able to say, okay, what's more specific that makes it just a rectangle?
Okay.
Okay, well, let's see. I know that in a rectangle, looking at just the diagonals, since that's what's marked, I know the diagonals are supposed to be congruent. So I could say that if I knew that maybe BD was congruent to AC, then it would be a rectangle.
Great.
Now, there's probably other things that I could have done. Because if I know it's a parallelogram, if I showed that maybe angle BAD is congruent to a consecutive angle to show that they were both right angles, angle ADC, that would be another way that I could show that.
I like that idea. Because you already know that in a parallelogram, opposite angles are congruent. So this angle is congruent to this, and this is congruent to that. But in a rectangle, all the angles have to be congruent because they all have to be right angles. So if you can show the consecutive angles are congruent, that would state that. Again, you're naming 2 segments or 2 angles that must be congruent.
Yeah.
And
you don't need both approaches, just one.
Just one. Whichever approach you do, just explain it. And she kind of already explained it. So with the first one, this was the diagonals idea. And so we already know it's a parallelogram. And in a parallelogram, the diagonals are also congruent. All right? Or in a rectangle. Yeah. This approach is talking about the fact that all the angles have to be congruent. And since opposite angles are already congruent, then the consecutive angles have to be congruent as well.
Right. Okay. All right. Now, I've got some pictures on here of some quadrilaterals, and I want you to think about what quadrilateral would meet the conditions shown below. But don't look at how they're drawn, because I purposefully did not draw them to scale because there's multiple figures that sometimes have these types of characteristics. Okay. So think about just the conditions that are shown. So let's maybe identify what conditions are shown here.
Okay, so in part A, I see one pair of opposite sides that are parallel. And I also see that the other opposite sides, not the same one, are congruent. And I stress that it's not the same one. The parallel sides are not congruent as well. Okay, if they were, I would be thinking a whole different quadrilateral. So what I'm thinking, if you only have one pair of opposite sides that are parallel and the non-parallel sides are congruent, that's an isosceles trapezoid. And it can't be anything else. Now, if the pair of opposite sides that were parallel were also congruent, that would make it a parallelogram.
Right. Now, could this possibly be a parallelogram? Maybe. We don't have enough information to determine that.
And that's the thing. It says what quad meet this condition for sure. This is like you're not going to have any kind of this is not a sometimes thing. This will happen always.
Right. Exactly. Okay, so looking at this next quadrilateral, what's the conditions that are given?
I see that opposite angles are congruent.
Okay.
And they're not all congruent because they're not labeled all the same tick marks. So the figure that I can think of with opposite angles are congruent is a parallelogram.
Can we get any more specific with that?
I'd have to need some more. It could be a rhombus, but the only way I know a rhombus is if all the sides were congruent. Rectangle and square would need all the angles have to be congruent, and that's not happening here. So parallelogram is as specific as I can go.
Right. So again, it's got to be, we know that it is this figure based off of just this thing, the stuff that we're given. We would need more to be able to get more specific.
Exactly.
Okay, great. Take a look at C.
All right, this is what I'm seeing. There's labeling on the diagonals, so I notice the diagonals are bisecting each other, which basically means, I know that's a property of a parallelogram. So that would mean it's for sure a parallelogram. Now, I'm noticing that not all those pieces are all labeled congruent, because if they were, I could say then it's a rectangle because rectangles' diagonals are congruent as well. But it doesn't have that. So I can't say rectangle, can't say it's a square. It might be a rhombus, but can't say it because I need to know more information. So for sure a parallelogram.
Right. Okay. Now, these are properties that, if it's a property of a parallelogram, it is a property that's true of all the others. We would just need more information. I like how you stated that. We would need more information to go further in depth. Okay.
So another question again, what type of quadrilateral is this? And it says explain. So looking at that picture, think about what you know, okay. What characteristics we know. Okay.
I'm looking and I'm seeing that I've got some consecutive angles. I could maybe call those base angles.
Okay.
That are congruent.
All right. So the base angles are congruent. So like what you're talking about is like angle
D and C.
D is congruent to angle C.
And A and B are congruent. And I notice also that A and D are also supplementary.
So if those are supplementary, what does that mean?
Oh, that means that I've got a consecutive interior angles that are supplementary would be parallel lines.
Okay.
Right? So I know that AB is parallel to DC.
Now, would that be true about AD and BC being parallel?
No, because those consecutive interior angles are not.
Like, if you look at it,
60s. They're congruent. They're not.
Okay, so we know for sure so far what you've had me label is that we have just one pair of parallel sides, right?
Right.
Is there anything else we can, because we're going to say what type. So what are you thinking so far?
Well, okay. Well, so I'm thinking it's a trapezoid.
Okay.
Because we've got one set of parallels. But as I'm looking at that, the base angles were only congruent with each other if it was an isosceles trapezoid.
And that you're exactly right. When that happens, that means AD is congruent to BC. So I can throw in the word isosceles as well. So be specific as you can. So that's the type. So it said, I started writing the explanation. So one pair of opposite sides were congruent. So that's one reason why it's a trapezoid. But why is it isosceles?
Because all the base angles were congruent.
Good.
Okay, we've got one more of these. We're just wanting to make sure you guys are good because, like we said, this would be a great test question. You might expect to see something like this on your final as well. This would just be a good test question. Okay, so what kind of quadrilateral do we have here? And we have a different type of quadrilateral, so this one is not going to be the same as what we found last time.
So it won't be what did we do last time, a square?
We did a square.
Yeah, it was a square, so.
This one's not a square, I'll just give you that much.
Okay. That doesn't help much, but that's okay.
It doesn't help much.
All right, why don't you sketch a little picture, and I'll start thinking out loud here. Okay, so we are trying to decide what kind of quadrilateral. We don't even know if it's parallelogram.
Yeah.
So we could start kind of the same way as we did on the last one.
Sure.
Decide if it's a parallelogram first, or if it's a trapezoid, or maybe a kite. Okay. Or you could find the distances of all four sides.
Okay.
Because that could also decide if it's a parallelogram, right? Because if opposite sides are congruent, then it's a parallelogram. So let's switch gears. Let's kind of switch gears.
Since we did all slopes last time.
Yeah, let's do distance formula. So let's find the distances of all four sides.
Okay.
So PQ, we'll start there. So the square root, so it'd be 0 minus 0 quantity squared plus 0 minus 2 quantity squared. So that means we get, that would be going to be square root of 4, which is 2.
Okay.
All right, let's move on. Let's just stick with, you want to do opposite sides? You want to just do that like we did last time?
That's up to you. You tell me.
Okay, let's do the SRS, just because I'm leaning towards maybe parallelogram, just because that's what we've been doing, but we never know. All right, so RS. So the quantity 5 minus 2 squared plus 5 minus 0 squared. All right, so that equals, that's going to be 9 plus 25, which is the square root of 34. Okay, so right away, I've already eliminated some things.
Yes, you know it's not a what?
It's not a parallelogram, which means it can't be rectangle, rhombus, or square.
Right.
So that means it could be a trapezoid. It could be a kite. Okay, so here's what I'm thinking. I'm going to stick with continuing the distances because it might allow me to prove if it's a kite.
Okay.
Because if we have some sides that are congruent, I haven't done with any of the consecutive sides. All right, so let's do QR. So QR would be square root of 0 minus 5, that quantity squared, plus 2 minus 5, that quantity squared. So it's going to be 25 plus 9 again, it's square root of 34. Okay. So that's that side. Now, that still hasn't really determined anything because we did talk about trapezoids could have a pair of consecutive sides that were congruent.
Right.
It doesn't determine if it's a trapezoid, but all right, let's do PS. So 0 minus 2 quantity squared plus 0 minus 0 quantity squared. So that's going to be the square root of 4, which is 2.
So right now, what figure is this?
It is a kite.
It is a kite. And we didn't get any more specific with kites other than just to say it is a kite.
Yeah.
So we're done.
So this is one where I only had to do 4 things, only because
of the approach we took.
Yeah.
Now, what if I went with a parallel approach like I did last time?
Then you would have to.
Would I have found any of these pieces to be parallel?
Now, then that doesn't mean it's a kite necessarily. It just means it just doesn't match any of the trapezoids, parallelogram figures. Then we would have to find the distances. So it's probably a good thing I did the distances on this
and
one.
I'll tell you that this is one of those things that a lot of kids want to go with the slope approach because slope's sometimes easier for us to do. But I'll be honest, guys, that if you do the distance approach, sometimes it's a little bit more telling up front of what kind of figures you're going to have.